In this lesson, we're going to look at the addition formula. Now, the addition formula is really for multiplying or expanding brackets with a cos in front of it or a sine. So we can see here that if you take the cos of 45 plus 30, then that's really just the same as cos 75, which you can work out as 0.25. What the question is this just the same as taking the cos of 45 and the cos of 30 and adding those two answers together? But if you look at that below, the cos of 45 plus the cos of 30, and you can try this in your calculator, that comes to 1.573. So these are not the same. You can't just say the cos of 45 plus 30 is the same as the cos of 45, add the cos of 30 independently. They're not equal to each other. So we need another way to work this out, the cos of 45 plus 30. Particularly if you've got the cos of x plus 30 or the cos of 45 plus y. So let's look at how you do that. How do you expand these brackets? So we're given this in the formula sheet, which is good because you don't have to memorise them, but you will get used to it and you will be able to memorise it quite easily. Now, to expand the sign of a value plus another value in brackets, then you just follow this expansion: sine of a cos of b plus cos of a sine of b. Sine cos cos sine, if you like, and the plus stays the same inside and outside the brackets. We also have sine of a subtract b, and it's the same idea: sine a cos b take away cos a sine b. When you expand the cosine of a value plus another value, then take the cos of a, multiply it with the cos of b, and then this time subtract sine a sine b. So it's a kind of cos cos sine sine, but the signs change and the plus goes to a negative. And with the cos a subtract b, then it's cos cos sine sine, but this time a plus. Now in the formula sheet, what you'll see is this idea below. You only see two formulas, if you like, but the top one encompasses these two. If you follow the top line, sine of a plus b equals sine a cos a plus cos a sine b. And then if you follow the bottom kind of line with the takeaway here, sine a take away b equals sine cos take away cos sine. And the same idea for the cos here. If you follow the top line with a plus, you can see in here you've got a takeaway, and along the bottom you get a takeaway, and then you get a plus. So that bit encompasses both bits here. So let's look at some examples and what this might be used for. So expand and simplify sine of a plus b first of all. So to expand that, you should be thinking sine cos cos sine, and the signs stay the same. So sine cos cos sine, and it's got a plus. With this idea here, once we start putting the values in, you can actually do a bit more to simplify it. So cos is cos cos sine sine. Again, you would look at your formula sheet if you can remember these, and the sign changes to a negative. So you'd end up with that situation here. Now at this point we need to do a bit more. We need to simplify down the cos 30 and the sine 30. We should know our exact values for these. So cos of 30, that's the same as the sine of 60. So that's root 3 over 2. So you're going to have root 3 over 2 cos x. Try and put the numerical value first. And then you're going to take away, and sine 30 is equal to a half, so you get a half sine x. And then we can take a common factor of a half out of here, and you end up with this. Another good use for this is to find exact values for angles that are not between 0 and 90 using the normal 30, 45 and 60 technique. So sine of 75, we wouldn't know that if we didn't know how to do this. So what you can do is, you can only do it with certain ones, but you can split 75 into exact values we do know. And the exact values we do know are sine 45 and 30 to make up to 75. And then we can expand this using our addition formula and work it out. So we're thinking sine cos cos sine, so write that out. And then these are multiplied and then added to these two multiplied. So sine 45 is 1 over root 2, and cos 30 is the same as sine 60. so that's root 3 over 2. So 1 over root 2 times root 3 over 2, cos 45, 1 over root 2 again, and sine 30 is a half. So we need to simplify this down. So multiplying fractions, just multiply the top and then multiply the bottom. So that's going to be root 3 over 2 root 2 plus, and that's going to come to 1 over 2 root 2. And then we've got a common denominator. So we can just set this as root 3 plus 1 over 2 root 2. Be careful in exams though, they usually like you to rationalise the denominator. So in this case you would multiply top and bottom by root 2 to rationalise the denominator.